Hi everyone. This marks your initial encounter with an LMS, Learning Management System, which is widely used in many education institutes. However, the system is not much common in school system, and I would like to use the benefit of the LMS system. So I wish to emphasize that our learning journey extends beyond traditional classroom methods. With the evolution of education, it is imperative to embrace modern tools for enhanced learning experiences. Let's delve into our first discussion on page 25 of workbook. So kindly refer to your workbook, page number 25, and this video provides you the complete answer to the question. The types of lipid consumed in the diet can affect the health of individuals. So we have discussed in the classroom this theory: saturated fatty acid and unsaturated fatty acid. Saturated fatty acids brings more health risk than unsaturated fatty acid. And also I have discussed this statistic part in the classroom last week. This is again recap of the statistic, and the statistic is very important throughout the AS lessons and also AL lesson. So this is important to have, that you can again and again watch this video about the statistic, and you never make any mistakes about the statistic, and you get the full mark. So tropical sprue is a disorder that limits the absorption of nutrient into the blood. Consumption of unsaturated lipid has been proposed as a cause of tropical sprue. So that means basically lipid is not much health benefit. Even unsaturated lipid can bring some kind of a health risk. The diagram shows part of an unsaturated lipid. Complete the diagram to show one possible structure of fatty acid, side chain of unsaturated lipid. So unsaturated lipid contains carbon-carbon double bond. It could be one or it could be several. So to get the marks, you have to show the carbon skeleton, and also you have to show at least one carbon-carbon double. Now when you're showing carbon-carbon double bond, so here I used to show it here, and the hydrogen atoms, they are in the one side. You can show up or down. So you can also show hydrogen one up, one down. We haven't learned, it is not in the syllabus. If one hydrogen up and one hydrogen down in the carbon-carbon double bonds, we call it trans fatty acid. Both the two hydrogen atoms are in one position, either up or down, we call cis fatty acid. So that's cis and trans fatty acid is beyond our textbook. Anyway, a little bit more learning. This is the picture, and next question. So I mentioned you in the classroom the basic statistics which is required for AS level. I'm going to recap the same story as it is very important lesson. Now when it comes to statistics, we should start with anything can happen when you take a chance. That means anything in this world can happen due to a chance. that is very important concept. Anything can happen due to a chance. So as you can see from the picture, we have some experience. People who try to make something claiming it has a value, that can happen due to a chance. That means we can't say this never happened, this probability is 0%. There is a small probability this can happen. And unfortunately, people take this as advantage to mislead the population. Just small percentage of chance, they exaggerate and they market it to make it money. So in science, we are not go behind the myths, we go behind the facts, evidence. So science is based on evidence-based learning. When it comes to experiment, investigations, research, we have a scientific method. It doesn't matter from your school, from your classroom, to the biggest universities like Oxford, Cambridge, Harvard, same method is practiced. So it includes, when we have a scientific question, we make an observation and then we ask a question. So we write a question, we write a hypothesis, that means assumption, this is happened due to this kind of a scientific base. And then number 3, you can see, so we conduct the experiment to test these assumptions and we correct the data. So our conclusion based on the evidence are the data. And after that, we analyze and make a conclusion. For the analysis part, we need statistics because it is a proven, globally accepted method. And then we can publish this data. So in statistics, one of the most important word is significance. So this is not an ordinary word in statistics. This is very much important technical word. So you should understand what is the meaning of significance. The meaning of significance, it is not happened due to a chance. It is happened due to a scientific reason. It is not happened due to a chance. It happens due to scientific reason. So, statistical significance refers to the claim that a result from a data generated by testing or experimentation is likely to be attributed to a specific scientific cause or reason, but not due to a chance. So, we are not minimizing the chance to 0. We minimize the chance to certain level like a 5%. So we talk about AL level, these things more. And here how we use this method with another way, like AS level, we have a method, a simple method to evaluate the result using statistical test. And A level, we directly use the more appropriate method is the statistical test. So statistical test will come for A level and we learn these things in A level. Now when it comes to AS, there's another important thing come up with the statistic just to hand, like a other side of the coin, like a reliability. The meaning of reliability is the conclusion, our result are very much powerful as we repeat the experiment, because measurements after repeating in the experiment. So you can see in this diagram, good accuracy, good reliability. Accuracy is our values, measured values are very close to true values. You can see all these dots, red dots are very close to each other. That means they are very close to true value, and we have done several times and we says this is reliable because experiment is repeated. So repeated experiment, as reliability is there then we can draw a statistical conclusion. Right, now let's take this example. I have a data. So this data represent two groups. Let's say one is the control group, the first group is the control group, and the second one is the experiment group. So this is the control group, and I have values 12, 13, 14, 15, 10 and 19. And the mean value is, you add all these values, divide by 1, 2, 3, 4, 5, 6, you get 13.8. The experiment group 5, 8, 7, 8, 11 and 16. Again, you get the mean value. Then the standard way is we plot a bar graph using this mean value. And you can see here, the first column 13.8 is higher, and second column the bar is 9.2. There is a reduction. So let's assume our experiment, we expect a reduction. So it could be a medicine. So we treat conditions, and the medicine helps to reduce these conditions to 9.2. Then what we do in statistics, the first set of data, we find the highest value and the lowest value. Highest value is 19, the lowest value is 10. In the second set of data, same thing we do. We take the lowest value and the highest value, 5 and 16. To make it valid, we're going to show the mean value range from its lowest and highest value. So then anyone can see what are the other values of this experiment. So like this, I'm going to show the 10 and 19 as a line. And then here 5 and 16 as a line. This is now called error bar. This line is now called error bar. Later, I will also introduce another term for this called standard deviation. At the moment, this is the beginning. We try to learn as an error bar. Error bar is, as I mentioned you before, the repeated measurements, how close to true value. True value is very close to 13.8 because it is a mean value. So we assume mean value is close to true value, and our other values range from 10 to 19. That means accuracy is also showing in this error bars. So if the line is shorter, our measured values are accurate. If the line is longer, our measured values are not that accurate. That is also important concept, the length of the error bar and also error bar itself. Now what we do simple method. We try to see whether the control one and experiment one, the error bars are overlapping. So we can draw a line like this, and we can clearly show the part of the error bar of group 1 control, part of the error bar of group 2 experiment, they are overlapping. Now this is the first set of data and how we interpret in statistically. Number 1, the data presented are reliable due to the presence of mean values and error bars. You should write in your answer exactly like this. So the data presented are reliable because it has the mean value and the error bars. Then you write error bars are overlapping. The second thing you had to write in statistics, the error bars are overlapping. The last thing, you make a conclusion, data are not statistically significant. So that means this data cannot be used because they are not statistically significant. If we use this as a medicine, okay, now we can't use this medicine, it doesn't make a statistical significance. Then only thing is they have changed the experiment or changed the concentration. Again, they have to repeat in a different way. Now the second thing you can also get another way like this. Now this is another data set. Probably we assume they have changed the experiment setup, the other variables and the concentration and some other things, and they generated this data. Now the control group 13.8 is the mean, the experiment group 7.1. So we again plot the bar graph like before, and then again we place the error bars. So here 19 to 10, and the other one 5 to 9. So error bars we show like this. Now we check error bars are overlapping. No, error bars are not overlapping. Then we make a conclusion. The data presented are reliable due to the presence of mean value and error bars. Error bars are not overlapping. Second point. Data are statistically significant. Now we can use this data to publish. The third and last scenario, we can have a graph like this. When you have a graph like this, we don't see anything. We don't know whether this is a mean value or one value. We don't know whether this is repeated or not. And we don't know statistically anything about this graph. In that case, you should also tell the data presented are not reliable due to the absence of mean value and error bar. And second thing you write, error bars are not there to analyze, so we cannot make any statistical significance. So these are the three scenarios you get when you're going to analyze data in the exam. So we coming to the last part of the question, the analysis part of the result, in which you're going to use the statistic. Fine. Now the provision to these questions, I can give a little bit of an insight because we haven't primed to this kind of information yet to do it. So, but we cover in the syllabus. It's coming up in the next one. So I think in next 2 class you will learn these things, and you get more advanced theory. This question is based on the experiment they have done to check whether feeding saturated fat or unsaturated fat has influence on the heart diseases. For example, this is the heart, and the blood vessel supply to the heart muscles is called coronary artery. Coronary artery is very important blood vessel, because if it is blocked due to this kind of a deposition of fat, we call it plaque or atheroma. Over the time, when people are getting older, human are getting older, especially males, there are many risk factors which cause making this kind of fat deposition in arteries. Eventually, it blocks the lumen of these arteries. So lumen is smaller, mean less blood supply to the heart muscles. Less blood supply to the heart muscle mean heart muscle cannot function properly and heart cannot pump blood to the body. So this is the main problem of the heart diseases. So this condition is called atherosclerosis, development of this fatty deposition over the time. And you can see in this diagram, one is completely open, no problem, there is nothing, and the second one start to develop the fat, third one halfway develop the fat, and the third one, the second one, the third one is completely blocked with a very small amount of lumen. So less blood supply. This is the process you see gradually developing in the blood vessels. Arteries is called atherosclerosis. It blocks the diameter of the artery. So that's important things you need to understand this question. Consumption of high level of cholesterol is associated with atherosclerosis. The development of atherosclerosis lesions, the lesions refers to the fat deposits was fed from the coronary arteries, and these develop into atheroma or plaque. So visible appearance of this fatty deposition over the time is called atheroma or plaque. In an investigation, one group of primates, the primates are very good to use because they are very close to human, the higher order animals, was fed a diet supplemented with cholesterol and saturated fatty acid. A second group was fed diet supplemented with cholesterol and unsaturated fatty acid. The first group fed with cholesterol plus saturated fatty acid. Second group, cholesterol and unsaturated fatty acid. The primates were fed these diets from a young age and then monitored over a period of 60 months. 60 months is 5 years. Now you can also raise a question, should we have a right to do this kind of experiment using animals, because the animal's life is jeopardizing by doing this kind of experiment? We'll discuss later that one. Primates are higher order mammals. That includes monkeys. So results, now coming to the results. This is a bar graph. This is the way we have to show a bar graph, and you should also learn this, because often you have to plot the graphs like this. So it should be clear y and x-axis. And when you make groups, two groups, these two groups together, you can see here two groups together, two groups together, two groups together. And also you should make an equal space. Try to make a space when you're separating. So here it is not equal here and here and here. If you take these three space, it's okay that not 100% thumb rule is you make a space, you separate the two graphs, and the key you should also show on the top or maybe side of the graph or somewhere here in the graph the key. So second graph, same way they showed the bar graph. Clearly they mentioned the mean and atheroma after 60 months. And male and female group, they have used a gender here. They are again separated into male and female. And we can also show statistics in this graph. Third result, that's graph 1. So let's come to the question then. Calculate the mean rate of increase in the surface of arteries covered in lesions from 15 to 60 months in the primate given saturated lipid graph 1. Remember graph 1. So we have to calculate using this graph 16 to 60 months the rate of percentage of surface of arteries covered in the lesions. Right. When we try to calculate the rate, it is very important to remember the change divided by the time. The rate equal change divided by the time. What is the change? The percentage of surface of arteries covered in lesion is the change. So 16 to 60. That's the difference you take and you divide by the time. So 16, the saturated lipid 2. And 60 months, the percentage increased to 52. So difference is 52 minus 2. Then you have to divide by the time. 60 minus 16. So I show here again rate divided by the change. 52 minus 2 divided by 60 minus 16. So answer is 1.13 square millimeter per month. This is the rate with the unit. The second question, calculate the ratio of primates with atherosclerosis given saturated lipid to those given unsaturated lipid at 32 months. So at 32 months, saturated and unsaturated lipid, the saturated lipid is 32, unsaturated lipid is 22. So 32 to 22 is the ratio. So 1.45 to 1. So what I did, first I write the numbers, then I divide it by the smallest number is 22. 22 if we divide, this side is 1, other side is 1.45. Right now, my intention here is to provide the statistical analysis of the data. So the second last question, I will also quickly go through it. Calculate the difference in the area of atheromas in males compared with the females in primates given saturated fats. Give your answer in micrometer, square micrometer. So here again I take this data. So mean area of atheroma in males 0.026, in females 0.04. So the difference is 0.022, and we have to change this to micrometer. So remember 1 millimeter equal 1000 micrometer. 1 millimeter equal 1000 micrometer. So you have to multiply millimeter to get the micrometer. Answer is 25 micrometer. Okay, now we are coming to the most important part of these questions. This is my whole intention to give you the analysis of the data, how you can analyze the data, and how you can use the statistical test to make a conclusion. These primates were fed a diet supplemented with cholesterol and earlier either saturated lipid or unsaturated lipids. Reduce the effect of these two diets on the development of lesions in the coronary arteries, atherosclerosis and atheromas. You can also notice there's a star here. When you have a star, you should be write your answer logical order, no grammatic mistakes, and you have to use the technical terms. You have to make a statistical conclusions, and the answer should be perfect to get the 6 marks. So I will train you to write different questions of 6 marks categories to get the highest marks, because at the end of the day, our intention, our goal is to my student should get the highest achievement in their test. Highest achievement is not restricted to the A, so I expect more than that. So that is my goal. That's why I do a lot of effort with my student to bring them to the highest level. So what is the meaning of deduce? Deduce is the command word of the questions. You should understand at the end of the AS all the command word and what you should write for this command word. Deduce is draw a conclusion from the information provided. So each result when you have to analyze and make a conclusion. Statistically, you make a conclusions. Increase or decrease, you analyze and make a conclusions. Now, this question, you have 3 graphs. So what you have to do, the format is you take first graph, analyze, make a nice paragraph, take second graph, again make a very perfect paragraph, another paragraph. So 3 paragraphs, enough, and you can label the paragraphs graph 1, graph 2, graph 3. That's a format. So you write a graph 1, write the conclusions, graph 2, write the conclusion, graph 3, write the conclusion. Sometimes we have to make a final conclusion to this all results, comparing 3 results to make a final conclusion. So here we don't want to make a final conclusion, and this is the format, deduce the result of 3 graphs. So I take the first graph now. First graph, we go one by one. So focus here. Okay, before that, the age and the percentage of surface of arteries covered by the lesions. Arteries have lesions with both lipids, saturated and unsaturated. Arteries fed with the lipids, they have a lesion, both overall increasing greater over with the saturated lipid. So saturated lipid is a dark gray area that has the greatest increase. Next one, type of lipid in diet does influence the percentage of arteries covered with lesions. So types of lipid, either saturated or unsaturated, has impact on the result. The percentage surface covered in lesions increase with time for both saturated and unsaturated lipid. So this is similar to this one and this one, but only thing is we also mention with the time it is also increased. If you take a one group 16, arteries have lesion with both lipids. So we can say it has both lipid lesions. Here both lipid lesions. Taking all, we can say with the time that's increasing. With the time, lesions increasing in both lipids. Now the other colored box here is called the statistical part. Data may not be reliable as no experimental details like mean or error bars. Repeatable as no error bars. Only once we cannot make a statistical conclusion. So arteries exhibit lesions containing lipids with the surface area affected by lesions increasing over time for both saturated and unsaturated lipids. This is the way we have to write in a nice English grammatical and technical form. We have to make a sentence to make the paragraph. The increase is more pronounced or increased, the more visible over time for saturated lipids, indicating that the type of lipid in the diet does impact the extent of artery coverage by lesion. So all the boxes with the yellow color is done now, and now the statistical part here, However, the reliability of the data is questionable due to the lack of experimental details and the absence of error bars, which may affect its repeatability. The second graph, percentage of primates with atherosclerosis with the age. So focus of this percentage increase with age for saturated lipid. So dark color one is saturated lipid, percentage increase for saturated lipid. Atherosclerosis occur in both groups. Similar to last question, both groups we can see atherosclerosis, but higher in saturated lipid. Atherosclerosis is higher with saturated lipid all three ages. Again, like the previous format, not only the 32, 60 and 60. Now, if you look the 16, 32, 60, you can see all bar graphs, they are higher. That's what we see. Atherosclerosis is higher with saturated lipids in all three ages. This one percentage increase with age for saturated lipid. So saturated lipid increase. So atherosclerosis occur in both groups. Age has a less clear effect with the unsaturated lipid. So now you can see this graph and this graph. Here comparing 32 and 60, can you see the 60, the percentage decrease. So here percentage decrease, here increase, then decrease. So rather saying increase and decrease, we say less clear effect with unsaturated lipid. Then the statistical part, data may not be reliable as no experimental details, repeatability, error bars, significant nothing. Atherosclerosis is more prevalent with saturated lipids across all three age groups, while the percentage of occurrence increase with age for saturated lipids. Conversely, the impact of age on unsaturated lipid is less evident. Then the statistic. The data presented may lack reliability due to the absence of experimental details, repeatability as indicated by lack of error bars, no mean value, statistical conclusion cannot be drawn. The last, we have a graph with the statistic on it now. The male and female, and mean area of atheromas. Okay. Atheromas are larger in both males and female with the saturated lipids. So dark, the gray bars here compared to this one. So male is higher. Look at this graph and look at this graph. Male is higher. Look at here 0. It's almost nothing. And look at here higher. That means the saturated lipid, the atheroma is higher, both male and female. So then the gender, sex is an influence on area as well. That means female less, male higher. So gender has an influence for atheroma. Males have atheroma of greater area than the female, whichever lipid they are given. So males, even saturated or unsaturated, compared to the female, they have a higher. So statistical part here, data likely to be significant because error bars, mean values, and the error bar overlapping we can check. The graph 3, atheromas are more pronounced or more evidence in individuals with saturated lipids compared to those with unsaturated lipids, regardless of gender. Males tend to have a larger atheroma than female, regardless of the type of lipid present. Gender plays a role in the size of atheroma. The data is significant as there is no overlap in error bar. Male data shows more variable accuracy compared to female. That means the error bar, the length is longer and this is the shorter. So as I told you, accuracy of the data we can also judge with the error bar. So I summarize everything in this slide now. This is my model answer for the questions, which contain 200 words. So writing 200 words with your analysis, it takes 10 minutes, so 6 marks question. Usually I recommend for student to do at the last because it needs time to write, time to think, time to make a good answer. So time 10 minutes may be enough for 6 marks questions, and I train you at the end to get the whole 6 marks for these questions, because there are maybe maximum 7-8 formats of 6 mark questions. So each questions I give a model answer like this, and you write it again in your workbook and try to understand and try to memorize certain statistical part. The same thing you can repeat in the words to get your full marks. So this is the most important lesson in this video for me, to give you a statistical qualifications, statistical skill to analyze the data. The second part, I finished this question. When we use animal in the experiment, there are two issues will come: legal issues and ethical issues. So legal issues, they are more written in the laws and punishable things. So ethical issues, it's about the social acceptance of use of certain things. So official rule accepted by the courts. This one is the rules of the social system. So many things we are using in our science, some are legal that we can't use, it's clearly say legal, but many are ethical. We can use with certain level of conditions. These are called ethical. That means we use, but one group of people argue, okay, this is not good to use the animals. Other groups say, this is good to use animal. So we have to write both to get the marks in our paper. So the unethical, we can understand always. If we use animals, they have a right to live. They cannot say, please use me for the experiment. That is called consent, the willingness to participate in the experiment. But human can say, no, I don't want to come to this experiment, or I can come to this experiment as a volunteer. And when we use animals, it might end up in lifelong disability or death of the animal. And some experiment, animal get pain. So these are the bad side of use of animal experiments. So we write it here. Unethical, because the pain of the animals. You can write this question as a bullet form, because we have a format answer. Whenever animals are used, these are the exact point in the marking scheme. So you can use as a bullet point, as strongly you get a mark. And the second one, this could lead to death and stress. The third one, they cannot give consent. They cannot say, I would like to come to this experiment. So this is against a 4. Against F4, this is 4. The primates, they are very close to human. So it is ethical to use rather than human. It's very difficult to use human, but ethical to use primates. So the research is actually done for the benefits of animal and human. So we can use the finding of the result for human and animal. Right now, this is the end. And I think this is the first experience for you in the started class recently, AS classes at Edexcel, both in Panadura and Malambe, and the third class I'm starting in Colombo and Nubegoda, because I usually take 15 students per group. Then these videos are common for all groups. I hope you will benefit from this kind of video in the future, and you also think, don't restrict it to traditional way of learning from your classroom. Go beyond that, and this LMS learning management system created for both IGCSE, AS and A-level have many valuable solutions, videos and other things, papers and model answers of the papers, and completely written papers with model answers which you never get anywhere, like this 6 marks question. So like here, so complete unit 1, unit 2 papers, you get these model answers that you don't find anywhere. So all you can get it from this LMS system in the future, and I provide all this information to my student. And so Same way, I will provide solution for another question in the workbook, but usually we learn theory and some short question like a 1, 2, 3 questions, mark questions. We are practicing always in the class. So please benefit this kind of the modern learning tools, and you mind setting. Don't try to just stay with the textbook and notes. Okay, thank you very much, and see you another time with this kind of video.